chapter 2, lesson 4, so on the quotient function. So investigate quotient. So before we get started, if we're now dividing functions, immediately what is a concern? Okay, order's good. What else though? Dividing by zero. Yes, we've created an issue for non-permissibles. Okay, we're putting functions on the bottom, but yes, the order is important. That's probably even the first thing you should think. But then division by zero is a concern now. Okay, so we're thinking about our non-permissible values, that kind of thing from math 20. Okay, so let's get this table put here. Okay, all right, so we're still doing the same thing. So f of x, 14 and 2. They didn't give us the stuff this time, did they? So they want us to go find it. Okay. Okay, so f of x in this case is, and then g of x is a line. Okay, so f of g is 7. F divided by g of 4 is 7. So let's go find 3. So 3 for my f of x is 6. And then 3 for my other one is 1. Okay, so 6 divided by 1 is 6. Okay, you're going to find the issue here. So then we have 2. At 2, I'm at 0 and 0. Can't do. Because you can't divide by 0, even if it's 0 over 0. It's an undefined spot. We'll talk about what that means in a little bit. 1, we're at negative 4 for f of x, and negative 1 for f, or g, I mean. So that means we got 4. At 0, negative 6, and negative 2 for 3. So it is being consistent at least. 7, 6, blank, we missed the 5. 4, 3, so we're probably taking 2 here. Negative 1, negative 6, and negative 3. Negative 2. They're the same spot. So negative 4 for 1. Negative 3, 0, and negative 5 for 0. And the last one here, negative 4, 6, and negative 6 for negative 1. So it was very consistent. Okay, so it's consistent in dropping 1 every time. It has one issue, but that means the output's going to be a what? Like in terms of a graph. What kind of graph is f over g? Linear. Good. It's linear. Okay. This. Go ahead. It doesn't bounce up. No, it's actually going to be a line with a hole in it. We're going to talk about it. So why it's a line? Because we're dividing an x squared, right? Just generally, we're dividing an x squared graph over an x graph, right? Well, x squared over x simplified as x. So that's again why it's going to be a line. Okay. All right. So then the questions on the bottom here. So explain why the domain of f of g cannot be XER. So why can our domain not be XER? Because of this spot here. Because that spot here. Because it has an undefined value. So we can't have x equals 2. Okay, so we'll write that down here. Function not defined at x equals 2. So we would write domain x can't be 2, XER. Oops, squiggly bracket, whatever. The other way, it's a little bit messier for interval. For interval, you have to go negative infinity to 2, not included, to infinity. So it's like you're doing everything but 2 is included. Yep, that's interval notation. Good question. Okay, sketch the graph. We already did that part above. And now they give us the functions. And you're going to see where the open stuff is. We do points of discontinuity more in depth in our rational functions section, but just good to see it now. Is that x squared plus x minus 6 was f of x. And then on the bottom was just x minus 2. Okay? So write and simplify an expression for the function including domain restriction. So right away when you see this, you see we can't be 2, right? That's a non-permissible. So that's why that's a domain restriction. Here's the interesting part. The top factors to that. And so what happens is this cancels x plus 3. That's the line that's there. That's the line that's there above. But we didn't put the line, did we? We can do that right now. Sorry, I thought we were just filling out the table. So x plus 3 is the line that we're making with that table. Now, x plus 3, but we don't have a 2. That 2 does not get eliminated as a restriction. You still can't have 2. Okay? So even though when you cancel, and we said this in Math 20, even when you cancel something, you don't lose that non-permissible. So we canceled it, so we still have the non-permissible 2. So x plus 3, right? So if we come up here, our other graph's going to be x plus 3. It would look like this. You start at 3. You have dots here. You have an open dot at 2. So it looks like this. That would be, this is f over g line. Okay? That's your f over g line would look like. Okay, any questions on that? Okay, we go a lot more into depth over, that's called a point discontinuity, and that will be more in depth in our later chapter of rational and radical functions. Okay, so let's go and evaluate this guy then. So f of g over negative 6, we can get this from the simplified version. So our simplified version was x plus 3. So negative 6 is not a non-permissible, so we can plug that in. So you get negative 3. So negative 6, negative 3 is on f over g of x. Okay? Negative 6, negative 3 is on f over g of x. Okay? All right, onward here. Okay, so in this investigation, the graph f over g cannot include the point 2,5 because 2 is non-permissible. So just so you know, and again, like I've said it twice already, but we will go over this more in depth for radical and rational. But see how it's 2,5 and it was linear? If 2,5 is not possible, is my range affected? Yeah, your range can't be 5 either. So your x not being 2, it's a line with a hole in it. So this y value of 5 never happens either. Okay? So your range gets changed a little bit as well. So your domain would be x can't be 2, your range can't be 5. Does that make sense? And that's because it's linear. Okay, it's because it's linear. Okay? And so that's what we're going to talk about here a little bit. All right, let's look at these. All right, f of g include any domain restrictions. Okay? Okay, so we're doing f over g. So we have 2x plus 5 over x plus 5. There's no simplifying to do here, but your domain restriction, x can't be negative 5. Right? Please don't ever do this move. I've seen it many times. You can never do that. Okay. You can never cancel the plus 5s. I see it all the time. Wish it can be nice and easy, and it's not. Those are attached. X plus 5 and 2x plus 5 are binomial and separated. Okay. All right, the next one here, x squared minus 2x minus 35. So I'm going to go ahead and just factor that. That's what this one simplifies to, and you can see we have a cancellation. So simplified version is x plus 5. The domain can't be 7. Okay. This time, we have two things in the bottom, or the denominator's a bigger, higher degree. X minus 2, x minus 3, well, that factors too, so we have a cancel again. If you cancel it, a 1's on top, that's if everything's gone. So that's your simplified expression. your domain still has two domain restrictions, 2 and 3. So domain x can't be 2 or 3 for XER. Okay, so there's your set builder notation. Okay, it only asks for the domain. You have to wear that range piece we talked about earlier. All right, so moving on here. Consider a function 2x squared minus 13x minus 7. When you see that, I hope you're knowing that's a quadratic, that's a parabola. When you see g of x, 2x plus 1, that's a line. Those domains for parabolas and lines is all reals. There's never issues with the domains. So the domain of f and g is domain of XER. Okay? Then we go to f over g. Now we have a domain restriction because we have a function on the bottom. I just put f and g. It's the same domain for both of them. Yeah, same domain for both of them. So just practice, even though you could have just kind of guessed and checked this, let's just practice decomp factoring. So remember, decomp factoring, 2 times negative 7 is negative 14. Factors of negative 14 to get you negative 13 is negative 14 and 1. That's what you're going to break the middle up to. Okay, so it's going to be 2x squared minus 14x plus x minus 7. Then you factor by grouping. So 2 comes out of 2x comes out of the first piece, gives me x minus 7. That's already an x minus 7, so we just say a 1 came out, which wouldn't change it. And so now you have your factor of the one on top. So 2x plus 1 over x minus 7, and then you can see we're over a 2x plus 1, because that's what g is. And so it simplifies to a nice, easy x minus 7. But it would have a whole where? Negative 1/2 for x, right? So x minus 7 is the line we would see. So we would have non-permissible. X can't be negative 1/2. You can find the actual point if you plug the 1/2 into the x minus 7, which means it'd be negative 6.5. But it didn't ask me for that, so it's fine. That's for, they say that part for the other chapter. Okay, so explain 2 ways again, f over g of 3. Okay, so the 2 ways is use a simplified version. So use x minus 7. So you would just do 3 minus 7. So just using your simplified x minus 7 to get it, you get negative 4. The other way is to do it separately, just like with multiplication. So what is f of 3? Yeah. These ways? No, you can do whichever. Yeah. No. No. It's just knowing you can do both ways. Yeah. F of 3 gives me 9, 18 minus 13 times 3 minus 7. So 18 minus 39, that's negative 21. So negative 28. So negative 28 here on top. And then the g of x, the g of 3, would be 7. And so negative 28 divided by 7 is negative 4. So you can just see they matched again. And so yeah, to Janet's point, we do not have to have one way or the other. They don't force you to do it one way. It's just unknowing that if maybe it's stuck with your simplifying, maybe do it separately. Okay, separately might be a little cleaner. Okay. All right. And the last page here. Zipping through, zipping through. All right, so consider 2 rational functions, 2x over x minus 1 and g of x over x over x minus 3. State domains of f and g. So my f domain, what's your f domain? X can't be 1? Right. Your g domain? X can't be 3. Okay. Now we're evaluate 3 times. So people get confused like this on this. This does not mean times. This means, let's see here, what's the best way to explain this? You have to do f of g of 2 and then multiply it by 3. So it's 3 times a function of 2. So this is like kind of like tied together because it's function notation. And so it's f of g of 2 times 3. Some people try to like distribute the 3 and they get 3f, 3g. It gets kind of crazy. Okay, so don't do that. So this might be a situation where it's probably easier to go ahead and go 3 times f of 2 times g of 2. So what is f of 2? So we go up here, we got 2 times 2 is 4, 2 minus 1 is 1, so 4 over 1 is 4, so this is a 4. G of 2, 2 on top, 2 minus 3 is negative 1, so negative 2. So you're looking at 3 times negative 8 for negative 24. Okay. Then we're going to try to add these guys. And it does get a little bit messy with that. Back to your rational equations from 20. Okay, so what we're going to do is we're going to go 2x over x minus 1 plus x over x minus 3. And so remember, if we want to put these together with addition, because we're doing f plus g, we want to simplify it. We want to get these as one fraction. So how do we do that? Common denominator. Good. Remember? So yeah, we do x minus 1 at top and bottom, x minus 3 at top and bottom to get the same denominator of x minus 3, x minus 1. So that means your top left is going to be 2x squared minus 6x. Your top right is going to be plus x squared minus x. Remember, don't FOIL the bottom, there's no need. So your simplified expression would be 3x squared minus 7x all over that there. You can pull an x out there if you want. It doesn't really particularly help you in this situation. You can. Okay, pull the x out, it's fine. It's good practice to do that. Helps you see. Okay. So then it does say state the restrictions. So your restrictions are still x can't be 3 or 1. Okay, you can go right. Set builder still is fine. Okay, and then we're going to get a little messy here with the f divided by g to finish. Okay, fraction over fraction. Okay. Okay, so 2x, last piece here. So we got the 2x, so we're doing f over g of x right now. And we're doing 2x over x minus 1 then, divided by x over x minus 3. So do you guys remember when we were doing rational functions in 20, where do you get your not-permissibles now? Right, all 3 of those spots cause non-permissibles, right? Because you can't divide by 0, so those 2, and then if that's 0, we're still dividing by 0. Okay, so now you picked up a non-permissible. So x can't be 0, 1, 3 now. So your restrictions have changed. And we're going to try to simplify this. Flip. So we're going to go 2x over x minus 1 times x minus 3 over x. You simply get a nice little x cancel here. 2x minus 6 top over x minus 1. You can pull that 2 back out if you'd like, but that would be the simplified expression there. Okay. So again, your non-permissibles are 0, 1, and